Alright, tonight's topic are the Platonic solids. Simply because they're interesting, I think, and I'm making a video. So, brief little bit of knowledge on the Platonic solids, which I believe to be important as they kind of make up the basis for sacred geometry. The tendency is in nature that these 5 shapes, which you'll come to find, are actually three-dimensional shapes made out of regular congruent polyhedrons. They're the only 5 that can be made in nature, and the tendency is in molecular structures, even up to biological, with the exception of fractal geometry, the tendency is, of course, that's what's called sacred because it's redundant throughout the universe, or it's repeated throughout the universe. These shapes are quite often made, we'll see, in the structures of the universe, for whatever reason, because I guess that will be my segue into. Does it count as a segue if you say that's my segue? Yeah, I guess it just makes you a sloppy talkologist or speaker-rologist. Okay, anyways, so you ask what's a congruent polyhedron? It is a 2-dimensional shape that has equilateral angles, which means they are equilateral, such as the square, pentagon, or the triangle, which are the 3 shapes that make up the faces of each of these are 5 Platonic solids. Now they call them Platonic solids after Plato himself. Now I'm not going to go into my own opinion about Plato, but I would like to say in my video that the idea of the Platonic solids was not founded in the originally in the mind of Plato himself. He's just one that brought it to whatever, it was Greek or Roman, and then it was recorded after that into what we consider to be modern civilization, into this actual age. But it's actually Kemetic science originally, and he brought it from Khemet, the land of Khem, which was in fact Africa, where he brought most of the things that he spoke of. I believe not all the philosophical ideas, though. That was his own, and that's the topic for another time. So, without further ado, we have the first one up to whatever we're looking at up for viewing is the hexahedron. Now you may know this is the cube. Okay, so if you've been calling it a cube the whole time, you say hexahedron, and in some circles they'll be like, "Oh, he's smart. Respect you for it." In some circles, they'll slap you around and say, "Pass the blunt." All right, so we got vertices. That's the points. There are 8 points. You may ask what the relevance of the mathematics of these are, but if you play around with the numbers and you're a nerd and watch Star Trek, or if you don't watch Star Trek, you may find that some of these the mathematics behind these are quite interesting. In fact, the vertices of this one, or metaphysically, it represents Earth, because it's the most solid, most structured, or the most efficient as far as stability. Its vertices are 8. Its edges, it has 12 edges and 6 faces. 8, 12, and 6 are the dimensions of the hexahedron. It is redundant. That means it can be put inside the octahedron. That's the next one, the octahedron. The cube can fit perfectly within this, and this can fit within the cube or the hexahedron perfectly. They're like sister shapes, sister solids. And of course its dimensions are, with the exception of the edges, are actually in reverse. Flip it. So the vertices are 6 and the faces are 8, but again the edges are 12. The edges are 12, faces are 6, and points or vertices are 8. When it comes to the hexahedron, it's the opposite with the octahedron. That's why they're considered redundant twins or whatever. There's probably a better way to describe that. In fact, I'm almost certain there is, but I can't think of it. I'm making a video now. I'm totally not going to cheat and look it up. So, anyways, the next one is the icosahedron. This one, I'm going to be using dice, like I am. I'm using gamer's dice. Some of you may be familiar with these gamer dice, like guess they use them in Magic the Gathering and Dungeons and Dragons and stuff. I don't know. I don't play any of that because I'm way too cool, if you could tell by the damn video. But anyways, it's like the biggest and it's most complex, at least when you're looking at it aesthetically. But it's the icosahedron, which represents water. Its vertices are 12 vertices. It's got 30 edges and 20 faces. 30 edges, 20 faces, and 12 points. Redundant with the dodecahedron, which just fell. The dodecahedron, according to Pythagoras, I don't know if I mentioned Pythagoras earlier, but Pythagoras understood the Platonic solids, as he was also a student of Kemetic science, mathematics, and spent, I think, a good portion of 30 years of his life studying in Africa, and he taught. He had a cult. He was supposedly a little bit strange. What would you call it? It was extravagant. But when he taught about the dodecahedron, in fact, he didn't teach about the dodecahedron, but we know metaphysically about these Platonic solids. And basically, we got from Pythagoras, and he did not. He forbade the speaking of the name dodecahedron. In fact, I think the name itself, dodecahedron, which is probably different in Roman or Greek or whatever, he forbade, just like he did the square root of 3, or the solution to the square root of 3, and something with 5. I don't know. It was forbidden knowledge because he thought if anybody found it out, it would be too drastic of a measure for someone to know that didn't have the proper wisdom to have that knowledge. So metaphysically, there's a few things known about the other shapes, but this one there's less known about it. But some would say that the universe is in the shape of the dodecahedron, and there's a lot of interesting things if you further research. But redundant to the icosahedron, its vertices are 20, its faces are 12, of course, and its edges are 30. If you remember, that was the flip for the icosahedron, so it fits right inside the icosahedron with every point matching up to a face, and the same as in reverse. And the dodecahedron is my favorite personally, but that's something that I like to go. I want to fit in it, and everybody likes the dodecahedron because it's the coolest. Now, the last one may look like the pyramids of Giza. Some of you may look at this and think, oh yeah, that's the pyramid. No, it's not. You're wrong. So I'm going to get you right. It's the tetrahedron, the icosahedron. I'm sorry, I'm reading the octahedron in the pyramid. See, can you see that? Yeah. See, like, where we at? That shape right there, the bottom of it. You can't see because it's shallow. Anyways, it's the octahedron that made the pyramids of Giza, and that the pyramid people built quite often, which is representative. This one's representative of fire, and with 4 points, 6 edges, and 4 faces. That's 4, 6, and 4. It's self-redundant. Fits inside itself. So it represents fire and the spirit. So you can go on when you think about this. Like, since it's self-redundant, you think fire. A unique element, but it represents spirit and passion, individuality, or would be representative of like the self-redundant and very powerful. And then, so when we started out with the hexahedron, this representative of Earth, and if you look at it, what would we say? It's it's 8, 12, and 6. 8, 12, and 6. 8, 12, and 6. Now, what does that have to do with Earth? I don't know. Some people study numerology, some people just know numbers, and some people know supreme mathematics, but you can look at it and think about what the numbers represent in a metaphysical sense and how they represent each of these shapes. Or you can look at it in an aesthetic way, because this, the octahedron, because you can hold it like this and spin it, see, like that. It's representative of air, and it could be windblown. It's dynamic air. The icosahedron, which represents water. See, look at that. Very complex in shape. The most faces of all the polyhedrons is emotion, emotion and things like the depths of the subconscious. And it's the biggest, most aesthetically dynamic die. And then the dodecahedron is just the shit. I guess, I don't know. You figure it out. Anyways, that's enough for tonight. I will bore you again later, but not with the Platonic solids, for we have covered that. Peace.